Got this Dr. Fong amp all back together. Brand new transistors installed on that channel. And going to do some output testing here. I'm using this equalizer set flat just so I can boost the input gain, because the computer itself doesn't have enough output voltage to drive the amp into clipping. So I've got my usual amp test jig set up here, a pair of 300 watt 8 ohm resistors, my multimeter with true RMS AC measurement, and my oscilloscope to tell when exactly I'm clipping. I need to turn this brightness down a little bit for the camera. There we go. And since these resistors get so hot, I'm using a fan to cool them off. I'm going to be putting quite a bit more power into them than what they're rated for. So let's get started here. I'm going to bring the left channel up just under clipping here. And it's going to be tough to get that exactly. I'll just call it that there. Look at that. 61 volts into 8 ohms, no clipping. Now it's going to drop slightly when I bring the second channel up, so I need to scope over to the other channel so I can see what I'm doing. Bring that one up just under clipping. 60.4. Let's go back over here and double check this one. Yeah, see now that one's overdriving. .58 volts. Boy, I can feel the heat off those resistors. But anyway, so both channels are just under clipping, and I'm going to call that good because I'm overheating my test load here. So we'll call it 58 volts into 8 ohms. Let's hope that the fan's not drowning out the microphone here. Do some calculations with Ohm's law, and we have current equals voltage over resistance, so 58 divided by 8 equals 7.25 amps of current, and wattage is current times voltage, so times that by 58, and we have 420 watts per channel RMS. Not bad at all. Not bad. That's with both channels loaded down at 8 ohms too. And this amp is actually rated for 4 ohms, so I can probably put quite a bit of juice in 4 ohms. It's right up there, 420 watts. It's right up there with a lot of newer amps I've worked with. So, coming right along. All I got to do now is some cosmetic work on the panels, and I might double check the bias sometime later on when I get around to it. I think it's right where it should be though, and I really don't want to mess with it because I don't have the schematic and I have no idea what the bias is supposed to be set at. I did, however, get the DC offset adjusted on both channels. You know, looking at those two potentiometers on the driver boards and where they were connected, my guess was correct on which one was the offset, so I was able to adjust that, and I got both of them at around 6 millivolts of DC offset, which is really good for a design like this. And for all that power this thing was putting out, it's not even really all that warm right now. Another thing I almost forgot to show, what I'm using for signal generation. It's just a simple Windows program called Function Generator Lite. Marchand Function Generator Lite. It's a handy little program. There's lots of programs out there that'll do the same thing, but this one tends to just be simple and do the job well, so I've been using it. I don't think it works on newer versions of Windows though. This system is still running Windows XP. It's actually that HP Pavilion FA-800 that I rebuilt some time ago. I had a video about. Another thing I'm going to do while I got this set up is I'm going to see how many volts are going into this amp from the input source, and then compare that to the output volts and calculate the gain that the amp has and the input sensitivity. Basically how many volts the amp requires at its input to reach full output power. And basically, just as I go on and test this thing, I'm going to be writing everything down and, you know, taking notes on it and make my own documentation on this amplifier with any of the specs I can come up with and things like that, because there is no documentation anywhere about this thing. But it is a very, very neat old amplifier that you don't see too many of these days.